All right, let's see if we can get this one done too. Find dy dx, and then we've got an equation that we really cannot hope to solve for y. When you see something like this is implicit differentiation. So you begin by taking a derivative of both sides. Y prime will pop up because of the chain rule, bink, and then you're going to solve for that. So take the derivative of both sides. Differentiate both sides. Why does that say comments? Go away, cursor. I curse you. Okay. Differentiate both sides. We're going to get 0 for this, 1 for this. So it will be just 1 on the left-hand side equals cosine of xy squared. But of course, it's not that easy. This is like chain rule where cosine is the derivative of the outside. But now we have to multiply by the derivative of the inside. The inside is itself a product. So we're going to be doing derivative of the first one. That's 1 times y squared, or just y squared. That's the first half of the product rule. And then I'm going to be doing plus x times 2y times y prime. Hey, look, it's the y prime that we wanted. Okay, now we need to go and solve for that algebraically. So the only way really to do that is to distribute this through the parentheses. I'm going to do a couple steps at once. I'm going to say 1 minus y squared cosine of xy squared, which is to say I took this and moved it over to the left. And then that's going to be equal to 2xy times cosine of xy squared times y prime. The reason I wanted to do a couple steps at once is that it gives me something easy to divide by. So I'm going to divide by that, and then I'm already done. Y prime equals this thing divided by this thing. 1 minus y squared cosine of xy squared divided by 2xy cosine of xy squared. Cool. Because it's an implicit derivative, we don't need to worry about the fact that we have x's and y's in the answer. That's actually something that you expect when you find a derivative using implicit differentiation. Okay, one more, I promise, this is the last one. And of course, I keep my promises because I'm a good person. Okay, so find the tangent line to the curve at the given point. This does not say that it's an implicit differentiation problem, but you should be able to tell because it has x's and y's in a way that would, this is possible to solve for it, but it would be messy. It's cleaner to solve it using implicit differentiation, especially because we're given not just an x, but also a y coordinate. So let's find dy dx, or find y prime, and that's going to be using the power rule, 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3. Don't forget your chain rule. Y is a function of x, so you need to multiply that by y prime. Anytime that y gets touched by a derivative, that's chain rule, baby. And then on the other side, derivative of 4, that's 0. Okay, this thing right here, that's what we're solving for. So I'm going to isolate that. Haven't used black in a while, so I'll use that. 2/3, and 2/3 can go away because it's 0 on the other side, and that means we can divide by 2/3 and it's kaput. So now y prime, if I do a couple things at once, it's going to be equal to negative x to the negative 1/3 over y to the negative 1/3. But putting negative 1/3 as a power and then putting it into a fraction, that's like really sloppy. So I'm going to say that that's equal to negative, and then I will flip it, y to the 1/3 over x to the 1/3. And even that's kind of, well, no, I guess that's not really that sloppy. Maybe I can think of it if I want as negative cube root of y divided by cube root of x. Okay, so now I want to find the slope of the tangent line. So y prime at negative 3 root 3 comma 1 will be negative cube root of 1, that's the y coordinate, divided by cube root of negative 3 root 3. Now, hang on, don't freak out, because a cube root of a root looks bad, right? But look at what root 3 times root 3 times root 3 is. It's 3 root 3, right? But hold on, isn't this root 3 cubed? Yeah, it is. So guess what? The cube root of 3 root 3 is root 3. So the bottom of this thing turns into just root 3 with the minus sign taken into account. That matters. And that minus sign gets pulled out to the front, competes with this one to become a plus sign. The top is 1. The bottom is root 3. And I'm going to say I don't really give a crap if we rationalize this because we're all grown-ups. So this right here is the slope. And then the point is negative 3 root 3 comma 1. So in point slope form, we've got y minus 1 equals 1 over root 3 times x minus negative 3 root 3. That's plus 3 root 3. And here, staring us right in the face, we've got the tangent line to the curve at the given point. Thank you very much for your patience. And I would say I promise that it'll be more fun next time, but I'm a man of my word and I don't really know if I can keep that one. But I'll see you next time.